Wait, so you came up with the model architecture when you were trying to relax?
Yeah. I used to like coding is like really relaxing for me. So it's kind of, I don't know exactly what I did this during the day, but yeah, my afternoon was like I was free, so I decided to code the architecture. So when I decided to implement GLiNER, most of the component was already there. Actually, all of them. It was just like, okay, taking this thing from this paper and then assembling them into GLiNER. Even the prompt based. So the GLiNER, it will embed like the entity representation into the model directly instead of predicting them. So I've developed something similar, but for question answering.
Okay.
So it was like just like borrowing code from my existing code base and making it into NER.
Hey everyone, I'm Mary. I'm a member of the technical staff here at Fastino Labs, and today I'm with Urchade, also known as Uzi, and he is the creator of the GLiNER family of models. And today we're going to talk about how he went from PhD thesis to a family of models with over 30 million downloads on Hugging Face. Uzi, thank you so much for talking to me today.
Thank you for the nice introduction.
Always. I want you to take me back a little bit to the point in your life right around when you came up with the first GLiNER model architecture.
So yeah, the GLiNER architecture, it was kind of an idea I had during several months. I wanted to develop it, so I had a list of research projects I need to work on, and GLiNER was like maybe in the top 5 in my ranking. So at some point in October 2023, I remember I just had my first publication, and then it was like one afternoon, I wanted to relax and do some coding and then try deciding.
Wait, so you came up with the model architecture when you were trying to relax?
Yeah. I used to like coding is like really relaxing for me. So it's kind of, I don't know exactly what I did this during the day, but yeah, my afternoon was like I was free, so I decided to code the architecture. So actually, most of the code component was like already developed during my PhD thesis. So during my PhD, I was working on span-based NER.
Okay. Can you briefly explain what that is?
Exactly. So traditionally, named entity recognition, the task was addressed using like BERT-like model, using the token level paradigm.
Sure.
So what it does is that for each word in an input sentence, it will predict if it is a start of an entity, inside of an entity, or not entity. So during my thesis, I wanted to kind of come up with new paradigm, like the span-based approach, which is to, instead of predicting in a token level, is to represent the segment in a text as a span.
Okay.
And then instead of classifying each token independently, the model is classifying the span directly. So this paradigm was already present before I started my thesis, but it was kind of like underexplored, I would say.
Okay.
So I decided to propose kind of new training algorithm, new representation learning algorithm to make it more powerful. So I have a bunch of paper on this subject. So yeah, so when I decided to implement GLiNER, most of the component was already there. Actually, all of them. It was just like, okay, taking this thing from this paper and then assembling them into GLiNER. Even the prompt based. So the GLiNER, it will embed like the entity representation into the model directly instead of predicting them. So I've developed something similar, but for question answering.
Okay.
So it was like just like borrowing code from my existing code base and making it into NER.
So basically, you said like the code for the implementation of the model, there were sort of blocks of it that were scattered. They were already written, and then it was just this one afternoon of relaxing that they all came together.
Exactly.
Okay.
So most of the component was already there, like all of them. It was just like assembling them. So I think during my thesis, I had like 17 papers. So
Okay.
what is good is that all this paper was actually useful for making GLiNER, which is really, I am really proud of that. So even if like some paper are not so like groundbreaking, like
Right.
some workshop papers, but I've developed some like little things in this that makes GLiNER possible.
Okay. And so you came up with this, like your head was in a really creative space, but was there a specific problem that you were trying to solve for when all of this came together?
Yeah, so for context, during my PhD, I was doing it at a company called FI Group. So in France, we have this special PhD contract called CIFRE. So it is like a collaboration between a public research lab with enterprise.
Okay.
So, yeah.
And what's the name of the public research lab that you
So
were a
it
part of?
was LIPN, Laboratoire Informatique de Paris Nord.
Okay.
So yeah, I was
Sounds
doing...
prestigious.
Yeah, thank you. So yeah, I was doing a joint PhD, I will say. So, so my work was kind of a mix of academic research, but sometimes, like my manager at FI Group, he would like ask me to help them in some like extraction tasks. So what we have found is that like using academic benchmark for like industrial application was really suboptimal. So we get like really poor performance. So what made GLiNER possible was the availability of LLM, which allow people to generate synthetic data.
Do you remember which specific LLM you were using to generate the pre-training data for GLiNER?
So actually, the data was not directly generated by me. So I've found out a paper they did like synthetics-based fine-tuning, but for llama, if I remember. They have fine-tuned llama on some synthetic data for NER. So when I've seen this data, I decided to take their data and use it for GLiNER.
Okay, so the data set was
already
pre-curated.
Yeah, exactly.
Pre-curated synthetic data, or was it a mix of some seed data and also synthetic data?
I think it was fully synthetic. So at the time they used maybe GPT 3.5 instruct, if I remember. And then they used this model to
an ancient
data.
model.
Yeah, very ancient. And then, so yeah, when I've developed GLiNER after implementing the architecture, I just took this data. I did one training run and then trying to eval and compare with available models like GPT or Mistral. I don't know if Mistral was available, maybe Llama at the time and Vicuna.
These are so old.
Yeah, very old. And then I've seen that like with like just maybe 2 or 3 hours of training, the model was able to have like competitive performance on a benchmark.
Okay, so let me summarize. You came up with the implementation in a day of relaxation.
Yeah.
And then you found a great data set that already existed. And then after the first training run, you realized you had something good.
Yeah, so I remember at the time, I think it was during vacation and the research lab was like closed. So, and then it was the first day I remember I implemented. And then during the weekend, I decided to go to visit my sister in a city called Tours. I went there and then he has like a big house. So it was really, and it is like a really calm village. And then, I spent one week and a half there and I did all the experiment during this time. And then, after that, I decided to submit the paper. So I wrote a paper on that in 2 weeks, and then I submitted to EMNLP. And that's it. And after that, I put the code on GitHub.
And this, just to be clear, this was before ChatGPT blew up, right?
Actually, ChatGPT was already available, but
no one was using it for writing long-form content.
Yeah, exactly. It was just like for implementing some like small functions.
Right.
But at the time it was like there was no like coding agent as we have now. So, but as I said, like most of the component was already available with my previous research project. So it was just like assembling them.
And so the assembly actually didn't take that long at all.
No, it was just like copying code and making things at the right place.
And was it accepted into?
Yeah, so it was accepted like in March 2024. But it became popular even before that, like maybe one month before that.
How do you think, or why do you think it became popular before the paper came out?
So actually, like when I've seen the results were really good. So I tried to publish it on Reddit, and so some people were interacting. So there was just like a small group of people that are using this model, and they found it really amazing. And then I tried to like present it at some workshop, but people didn't really care about it because the workshop was not so focused on NER. Yeah, and then at some point, I decided to write something on Hugging Face. So I think on Hugging Face, they just allow people to like post something. So I decided to write a post on GLiNER. And then one engineer from Hugging Face found my post and then decided to look into my repo. And
was it Tom Arson?
Yeah, it was Tom. So, and then he decided to make a post on LinkedIn. And I remember the post was like really popular at the time. It got like 2,000 likes.
So that's when you knew.
Yeah, and this was maybe in February or March 2024, and became really popular.
Okay.
Actually, I remember at TMNLP, like the review were not so great. Like I had some much better paper with, but I think the reviewer were not so accurate at measuring what will be the impact. But fortunately, there is the meta reviewer. He kind of championed the paper that made it accepted. So thanks to him.
So this was your PhD thesis?
Yeah. Actually, GLiNER is like kind of one of the last project of my PhD thesis.
So you had other projects?
Yeah, I had a lot. Actually, GLiNER, at the time, GLiNER was not even my favorite paper. Like I have a lot of paper I prefer above GLiNER, but they are just not useful. But what is good with them is that all of this paper, even if no one are using them, they kind of give me the knowledge to build a model like GLiNER. So what makes GLiNER work is actually that. So during my thesis, my thesis was about creating better training algorithm and decoding for machine learning, like information extraction in general. And what I've realized that as you make your model complex, the performance will be poor.
Right.
So most of these models are like really complex, a lot of mathematical equation, like really beautiful. But the performance is like really bad. No, not bad.
They can generalize to the real world.
They are really good at small scale, but as you scale, the performance is not so good. So I've learned from this paper to make GLiNER. So my idea with GLiNER, okay, let's make the model as simplest as possible, like a really simple objective function. Instead of predicting the label, just embed them as a brute force into the input of the model. I kind of knew in advance that it would work, but I just didn't realize that it will be better than these large LLMs.
Yeah, I mean, that would be hard to have predicted, I think.
Yeah.
Especially at that time.
Yeah, exactly. And I think that the synthetic data, actually my first ever paper, even during my PhD, before my PhD, was on synthetic data. Because what is good with synthetic data is that you can scale data.
Right.
Like, and you can also guide it to kind of steer your model into certain capabilities. Right. And I think many people are using that now, like for making LLM having some capabilities, so they will generate synthetic data and then fine-tune the model on them.
Yeah, and it solves the data scarcity problem. As well.
Yeah, and also, like we tend to think that academic benchmarks are high quality, at least me at the time. And then the thing is that many people or PhD students, they will just like take a data set and then train their model on it without looking into the actual data. But actually, when you look at the actual data, the quality is really poor. For academic research, this is okay, but for industrial application, as was what I noticed during my time at FI Group, it just the performance is too poor to make it into production.
Do you feel like your experience doing this sort of like dual study and work program actually really primed you for what you do at Fastino Labs, because it's a model that is not just conceptually good, you know, or impressive. It's something that is, yes, conceptually impressive, but also can generalize to many tasks and can work in real world situations.
Yeah, exactly. So at Alpha Group, my manager, Pierre, actually did his PhD with the same advisor as me. So every time I come up with new idea, like new cool idea, he will tell me, Urchade, oh, this is a really good idea, but we also want it to be useful.
Right.
Yeah. That actually, like, he really shaped my mind. Like in my academic advisor, they will want to like make something novel, but Pierre, he was like
wants to make something useful.
pushing me to make like both, something that's both beautiful but also useful. So yeah, it's really helped me to do that kind of PhD.
Yeah, and I think that's a really nice way to describe GLiNER, both beautiful and useful.
Exactly.
Yeah.
Thank you.
Of course. So, stepping back here, can you tell me at a very high level how GLiNER works in terms of what is an input that it takes and what is an output that it gives?
Okay, so GLiNER as input, it will take, so you have like an input text. And
so
then,
a sentence?
Yeah, a sentence, for instance, and a set of entity types, for instance, person, organization, location. And then you will embed that into a encoder model such as BERT. So you will get a representation for each word from the sentence.
So you have a representation from each word from the sentence. You also have a representation of each of those labels.
Yeah, exactly.
Okay, so and these are in the same multi-dimensional space.
Yeah, in a shared representation space. And then the sentence block, we will represent like every span, every segment from the text. For instance, instead of just representing one token, you can represent token like a segment of length n, for instance. And then from that, you will perform a matching between the entity representation with the span representation. And this is how we score, for instance, if a span like Mary, you will match it, you will compute a matching with an entity type like person, organization, and location. And you optimize the fact that the score with person is higher than other labels.
Right. So if you have an input sentence that says, Mary works at Fastino Labs.
Yeah.
So you have Mary works at Fastino Labs. And then the second input you have is a list, and that's going to be person and say company.
Yeah.
And so then the output from that is going to be?
Yeah, Mary is a person and Fastino is a company. Yeah.
And is there going to be a confidence score for each of these?
Yeah, we use so-called sigmoid function activation that map like a real value into probabilities from 0 to 1. So we optimize it with an objective function called the negative log likelihood, so that to simulate the kind of probability from the model. So yeah, so for each pairs of entity type and span, you will have a confidence score.
Okay, so we have the sentence, Mary works at Fastino Labs. The output of it is Mary, person, probably a high probability score, and then Fastino Labs, company. Yeah. Probably also high, but maybe not super high because, you know, Fastino Labs is kind of new.
Yeah.
Okay, so we feed in the sentence and we feed in the entities that we want to extract. Yeah. Now, when you pre-trained GLiNER, obviously you pre-trained it on a whole host of entities and in other languages as well, because GLiNER is
actually
multilingual.
Only English, but yeah.
Oh, okay.
I can explain why it will transfer to other language. Like
yeah, please do.
Shot.
Yeah.
So yeah, so when I published GLiNER, when I was working on it, I think I will not I will not take credit of everything, because I was like asking GPT, like, what kind of experiment can I add to my paper?
Yeah.
And I only did like English experiment in my paper. And then GPT was, oh, maybe you can do a multilingual experiment. But the thing is that I didn't have multilingual data set. So how would I do that?
You just trained on English?
Yeah.
Okay.
And then I was thinking, how would I make like a really good multilingual model with only English data set? So and then so I've evaluated my English model with multilingual data set, and the performance were not so good. So well, something I've tried is that, okay, let's take a multilingual base model, so the multilingual DBERTA, and then train it on English. The thing is that if you naively train it on English, there will be something called catastrophic forgetting.
Right.
Even if your model is multilingual, if you train it on English, it will forget like the knowledge learned in other languages. And then what I did is that, okay, what we want is that we want the model to learn the NER task, the name entity recognition task, while keeping the previously learned knowledge during pre-training. So what I did is that, so I took the backbone, the DBERTA, and then I train it with like really small learning rates, so that the weight does not change too much, so that it keeps as much knowledge, multilingual knowledge, as it was.
To reduce the chances of catastrophic forgetting.
Exactly. And then use higher learning rate for the GLiNER layers, so the layer I've added on top of the base model. And then from that, and then I've evaluated on Spanish, Chinese, Russian, and then I've compared with ChatGPT, and the model was like 5% better without multilingual data. And that was, I was really proud of this experiment. And it was ChatGPT's idea, so.
So it was like a tag team.
So it was nice.
Okay, and kind of going off of that, then can you explain how, so you pre-trained it on specific entities, but it also works as a zero-shot model. Usually when we talk about zero-shot, usually we only think of decoder models.
Yeah.
But can you just tell me a little bit how you pre-trained it, also how you can fine-tune it on different entities, but then it can also generalize on a zero-shot level? That is, I think, from the training data. So the training data, I don't remember exactly the name, Universal NER, that was the training data. So this training data, it contains 14,000 unique entity types from it. In English or multilingual?
Yeah, in English.
English, okay.
Like it can range from like really coarse-grained entity types, such as person, organization. But if you look into the data, there will be like entity types such as Pokemon, plant. So it is really diverse.
Okay.
And it was generated from the PILE data, PILE data set. It is like a data set that people use for pre-training LLMs. So it's really diverse. It contains codes and
addresses.
Blogs, many types of data. So the entity types extracted from this data is really diverse. So when you train your model on that, and since these entity types are embedded directly like in a semantic way, using their natural language representation, so the model will generalize from that. So because it is optimized to kind of even know really specific entity types. And then from that, and something interesting I've seen is that, like, for instance, if you want to extract entities, but for like Spanish text, what I've found is that if you put the prompt in English, it will work better than if you put the prompt, like the entity types in Spanish. That was really good. I don't really understand why it is the case. Maybe just this model are really good at representing the learning the training language domain. So actually, and then when I came to the EMNLP conference, I've seen a research from Microsoft where they have seen that for multilingual tasks it is better to put English prompt, and that kind of the same thing.
So it's, I don't
know if it is still the case now.
Yeah.
But it is really interesting. Let's say you want to address a text in Arabic, but instead of putting your prompt in Arabic, you will put it in English and it will work better. And this is the case as well for GLiNER.
So there's still some level of mystery around how models like GLiNER work.
Maybe this is not true anymore. I don't know, because people, like, the data get better in other languages. But before, the dominant language was English. Yeah.
And so what would you say, what are some of the top most popular use cases for this GLiNER model?
Yeah, so when GLiNER comes out, like, many people were using it for PII. And that's why I've decided to develop the GLiNER PII base, small and large at the time. I think PII is like the dominant use case till now. And then later NVIDIA published their own fine-tuned of it. And I think PII definitely is really, really popular for.
And how many, when you're fine-tuning GLiNER for PII, how many different types of entities of PII did you fine-tune it on? Which PII stands for personally identifiable information, so things like social security numbers, etc.
Yeah, I think the first version of GLiNER PII, I didn't really cap the number of entity types. I was like generating synthetic data and prompt the LLM to generate like just a PII labels without specifying them. And I think it was more than 1,000 types. But then later, GLiNER 2, like our latest model was fine-tuned, if I remember, on 54 PII labels. Okay. So to make the model more focused on these like types.
Yeah, the specific domain.
Yeah.
Okay. And you mentioned that NVIDIA fine-tuned a GLiNER model for PII. Was this a surprise to you, or how did you find out about this? How did you feel when you found out that NVIDIA picked up your model?
Yeah, it was huge. I guess, if I remember, it was at a time where NVIDIA came like top in terms of valuation or something like that. And I was like, I told my mom, the most valuable company in the world is using GLiNER. That's crazy. Yeah, and even Meta is using GLiNER as well. And like even my grandmother who is in a village in Madagascar is using maybe indirectly GLiNER, and that is, that like I'm really proud of that.
Wow. Okay, Uzi, thank you so much for sharing with me everything about GLiNER.
Yeah.
It's so, I find it so interesting how you came up with it, and that it wasn't like an absolute slog for months on end. It was more like months and months of learning and probably ideas sort of like marinating in your head, and then it all came together.
Exactly.
Kind of at this exciting, almost like a moment when you were already relaxed.
Yeah, exactly. Like it was during my last year of PhD. So, and GLiNER is not just an idea that came out like miraculously. It was like a learning from like a lot of failures, a lot of experiment, a lot of, trials and errors. And it was kind of a reward of all of the hard work I did during my PhD, I think.
Well, thank you so much for sharing all of this with me, Uzi.
Thank you for the interesting question.
You're very welcome.
It made me remember a lot of memories back during my PhD.
Nice and nostalgic.
Nice.
Thanks, Uzi.
Thank you.